We're going to do two problems in this section. One of them is a really short problem. The other one's a little bit longer, a little bit more involved. It's another collision at an angle. Fish is moving at 2 meters per second. Swallows a stationary fish, which is 1/3 of its mass. What's the velocity of the big fish after dinner? So obviously this is going to be an inelastic collision. We have two things and they become one thing. And so because of that, we've got that inelastic collision. So we know that the original momentum, sum of original momentum, should be equal to the sum of the final momentum here. The original momentum was basically just 3 times the mass. That's the little fish is m, the big fish is 3m. So we've got 3m times 2. And we know that the little fish doesn't have any momentum. And that should be equal to the sum of the masses times the final speed. If we just go through here and we say that m is 1, we'd have 6 on this side. We'd have 3 plus 1 would be 4 on this side, and that would be times vf. So our final speed here of the two fish together should be 1.5 meters per second. So that's a pretty simple problem just to work through. Kind of an easy one to do. Next one's a little bit more difficult. You have a couple cars. You have a car with a mass of 950 kilograms. It's moving at a speed of 16 meters per second to the east. So let's draw a little box for the car. And here is the car. It's moving in this direction at 16 meters per second. And there's a minivan coming into the same intersection. Unfortunately, somebody's not paying attention, or somebody's texting or doing something, and they come and they collide together, and when they collide, they stick together. So this is another inelastic collision. When they stick together, they're probably going to go off in an angle like this. So if we drew a diagram that kind of shows the momentum, we would say that the resulting momentum should be equal to the addition of the two vectors that we have, so the momentum in the y and the momentum in the x, and then we can relate the momentum in the y and the x to find out what the angle is that they would take off together at. So we know that the sum of the initial momentum should be equal to the sum of the final momentum. If we divide this kind of down the middle, we could say that the sum of the initial momentum in the x should be equal to the sum of the final momentum in the x, and the sum of the initial momentum in the y should be equal to the sum of the final momentum in the y. For this one, the initial momentum, if we look at just the x direction, notice the only thing in the x direction is the car. So it would be the mass of the car times the speed of the car, and that would be equal to, when they both go off together, the mass of the car plus the mass of the van, and then their speed would be the same. So that would be the speed, final speed in the x direction. On the other side, I've got the mass of the van times the speed of the van, because it's the only thing that's traveling in the y direction. And then they are together traveling in the y direction, so that'd be the mass of the car plus the mass of the van times the final speed of both objects moving. When they move in this direction, they've got a component going up and down. The momentum, and what we're going to do is just find the absolute value of the momentum, should be equal to the square root of the momentum in the x squared plus the momentum in the y squared. Because our objects, this is really easy to do because one's moving in the x, one's moving in the y. We don't have a lot more to do on this one. This would be the square root of the mass of the car times the velocity of the car squared, plus the mass of the van times the speed of the van, or the velocity of the van squared. If you plug all your numbers in, you'll find out that the absolute value of the momentum should be 31,246 Newton seconds. Remember, we could also do a kilogram meter per second. If we go back and think about momentum, we know the absolute value of the momentum should be equal to the mass times the absolute value of the speed. We want to find out what the speed is, so the absolute value of the speed should be equal to the momentum of the system, and the system consists of the car plus the mass of the van. If you plug those in, you put 31,246 on the top. On the bottom, you put the mass of the car plus the mass of the van, And if you do your math, you should end out with 13.9 meters per second, and that would be the final speed of both objects. The thing that we need, because it says velocity, is we also need to know what is the angle that it makes. So remember, we said that would be equal to the inverse tangent of whatever our y value is divided by our x value. So if you know the momentum in the y and you know the momentum in the x, and that's pretty easy to do, you just multiply the speeds times the masses for each one, you should end up with 60 degrees north of east, and so that angle would be right here, and this would be 60 degrees. That makes sense. The mass of the van is bigger and its speed is higher, so it should push it more towards the this direction. So probably your angle is going to look something a little bit more like that, and a little less like a 45-degree angle like what I drew it. And that is the end of the car crash example problem.